Two speakers S1 and S2 driven by the same amplifier are placed at y equal to 1 meter and y equal to -1 meter. The speakers vibrate in a phase at 600 Hz. A man stands at a point on the x-axis at a very large distance from the origin and starts moving parallel to the y-axis. The speed of sound in air is 330 meter per second. At what angle theta will the intensity of the sound drop to the minimum for the first time? Fine, let's say this is my point O and I have to calculate the value of theta. This value, let it be capital D. The distance between the two sources, let it be small d. And let's say this OP distance by. Fine, so clearly I can write tan theta is equal to y by d. Right, now what I'll do is I'll connect S1O and S2O. Right, and what I have to calculate is so that the intensity is dropped to the minimum at point O. So for minimum we know that part difference is given by 2n plus 1 of lambda by 2, and for the first minima n should be equal to 0. So delta x comes out to be lambda by 2. Now this part difference delta x will be equal to what? S2O minus S1O. So what I'll do is I'll make a construction like this. From the point S1 I drop a perpendicular on, let's say this point is my B. On OB line, let's say this point is A. Fine, so by dropping a perpendicular on OB, what I did is that the line OB is now the perpendicular bisector of S1A. So it shows me that S1O is equals to OA. Right, so the part difference between S1O and S2O will be only due to this S2A. So I just calculate the value of S2A and that will be my part difference. Right, now if this angle is theta, this angle will also be theta. So I can write tan of theta as S2A by S1 S2 distance, that is D. So S2A, that is the part difference, is given by D tan of theta. So it comes out to be D tan of theta, and we know that tan theta is equal to y by D. So D comes out to be y by capital D. This is my part difference delta x, and that is equal to lambda by 2 for the first case. Now I just have to calculate the value of theta. So y by d is also theta. I can write d tan of theta is equal to lambda by 2. Let's calculate the value of lambda first. Lambda is given by wave velocity divided by frequency. Substitute the values. Wave velocity is 330 meter per second divided by frequency, that is 600. Fine, and substitute this value over here. I have the value of d as 2 meters because the distance between slit is 1 and 1, so it will be 2 meter. Tan of theta is equal to 330 by 2 into 600. Fine. So tan theta can be written as 7.9 degrees. If you solve them, it comes out to be 7.9 degree. Now one thing that it is very clearly given that the man is standing on the x-axis at a very large distance. So d is very greater than y. So what I can say is that theta is very small. So tan theta is approximately equal to theta. So theta comes out to be 7.9 degree. That is the answer for the first part. In second part, at what angle will he hear a maximum of sound intensity for the first time? Right, now for the first maxima, what I know is that the part difference is equal to n times of lambda, and for the first one n is equal to 1. Now I know the part difference as I calculated above, that is given by d tan of theta, that is given by lambda. Just substitute the value. D is 2 tan of theta and the value of lambda is 330 by 600. So the value of tan theta comes out to be 16 degrees, and as I took the assumption tan theta is almost equals to theta, so theta is equals to 16 degree. That is the answer for the second part. In the C part, if he continues to walk along the line, how many more maxima can he hear? Now clearly we know that path difference is given by n lambda, that is the condition of maxima, and for more maximas n value varies from 2, 3, 4 and so on. So the path difference if varies like 2 lambda, 3 lambda, 4 lambda, I'll get successively more maximas. Fine, and as I know that delta x is given by 2 tan of theta, so just substitute the value of n lambda as 2 lambda, 3 lambda, 4 lambda and so on. You get the value of theta successively as 32 degree, 64 degree, 128 degree and so on. Now if he is continuously walking on a line that is parallel to y-axis, right, so theta cannot be more than 90 degree. That is for sure. Theta has to be less than 90 degree. So the only two possible maximas will be for those whose angle is less than 90 degree, that are 32 degree and 64 degree. So he will get two more maximas and they are at angle 32 degree and 64 degree. That is the answer.